When you remove a programming language that is referenced by a friend, you will get an exception when you try to save. In this demonstration, you will learn how to catch the exceptions when saving, and you also learn how to check if a programming language is referenced by a friend. Let's start with the exceptions. Here I've started the Friend Organizer application in debug mode. Now I open up the friend Tomasuba and you can see that my favorite language is TypeScript. I go to Edit Programming Languages and now I remove TypeScript and I click Save. Now we get a DB update exception in the onSaveExecute method of the Programming Language Detail View model. The exception says that the delete statement conflicted with the reference constraint. For sure we know that the friend was referencing the programming language. Now let's stop the application and let me add a try catch block around this code here in the onSaveExecute method. I want to catch any exception here. For that catch block I have prepared a little snippet. While the inner exception is not null, I store this inner exception in the X variable. Then I use the message dialog service to show an info dialog. I say error while saving entities and the data will be reloaded. And I display the message of the exception. After this, I call the loadAsync method of my Programming Language Detail View model to reload the data from the database. Now let's run the application and let's see how this works. I open up Tomasuba and I'm still referencing TypeScript. So let's go to Edit Programming Languages and let's remove TypeScript and let's click Save. Now we get this info, error while saving entities, the data will be reloaded. And we get the details of the exception. I'm sure you can build a nicer exception dialog for the user, but let's not focus on this task. I click OK and now you see we are back in the previous state. The TypeScript language is back. Now let's see how we can avoid the exception by checking if the language is referenced when the user tries to remove the language. Here I've opened the iProgramming Language repository interface. As you can see, I have added this new isReferencedByFriendAsync method that takes the programming language ID as a parameter. It returns a task of bool. In the programming language repository, I have implemented this method. From the context, I grab the friends DB set as no tracking because I don't want to track the friends with this context. I use the anyAsync method to check if any friend's favorite language ID property is equal to the programming language ID parameter that we receive in this method. I await the result and I return it from this method. In the Programming Language Detail View model, I use this new method. Here you can see the onRemoveExecute method and I have added this block before the actual remove logic. Here I call the new isReferencedByFriendAsync method of the programming language repository and I pass in the ID of the selected programming language. I store the result in this isReferenced variable. Then I use this variable as input for an if statement. And if the programming language is referenced, I show an info dialog by using the message dialog service. The message is the language and then the name of the language can't be removed as it is referenced by at least one friend. And after displaying this info dialog, I jump out of this onRemoveExecute method by using a return statement. Let's see this in action by running the application. I open up Tomasuba and you can see I'm still referencing TypeScript. So let's go to Edit Programming Languages and let's try to remove TypeScript. Now we get the new message box, the language TypeScript can't be removed as it is referenced by at least one friend. When I go back to Tomasuba and I change the favorite language here to C# and I save, and I go back, then I can remove TypeScript from this Programming Languages data grid. Now we are done with this Programming Languages detail view that is used to maintain a collection of programming languages. Let's wrap up what you have learned in this module. You learned in this module how to integrate a detail view for collections in the Friend Organizer application. Now the user can edit all the programming languages used in the Friend Organizer application in a single detail view. After we did the view, you also learned how to check if entities are referenced. So if at least one friend is referencing a programming language, the user can't remove that programming language from the Friend Organizer application. In the next module, we will focus on multi-user scenarios. What happens if two users are editing the same friend at the same time and then they save that friend back to the database after each other? You will learn how to handle this and other multi-user scenarios by using optimistic concurrency with Entity Framework. Welcome to the module Implementing Optimistic Concurrency. My name is Thomas Claudius Huber. When multiple users are using your application, it might happen that some users are editing the same data, which can lead to conflicts. In this module, you learn how to handle these conflicts by implementing optimistic concurrency with Entity Framework. Let's take a look at the module outline. We start this module with a typical multi-user scenario. Two users are saving the same friend back to the database. So which changes are stored in the database? The changes from user 1 or the changes from user 2? After you have seen this scenario, you will learn about ways how to handle concurrency conflicts in your application. You will learn what it means to use pessimistic concurrency, and you will learn what it means to use optimistic concurrency. After you know what optimistic concurrency is, you will implement optimistic concurrency in the Friend Organizer application with Entity Framework. This means that you will add a row version to the friend entity in the Friend Organizer application. This row version is updated whenever the record in the friend table has been changed. When the user loads a friend in the Friend Organizer application, it will have that row version. When the user edits that friend and saves it back to the database, Entity Framework will check if the row version of the edited friend is still the same as the row version of the friend in the database. If that's not the case, that means that another user has changed the friend in the meantime. Then Entity Framework will throw a DB update concurrency exception. You will learn in this module how to handle the DB update concurrency exception to give the user two options. The user can either say, I want to save my changes anyway back to the database and overwrite anything that has been changed in the meantime by another user, or the user can say, I want to discard my changes and I want to reload the data from the database. So far to the content of this module. Now let's see what happens when two users are saving the same friend in the Friend Organizer application. In this demonstration, I will show you what happens when two users are saving the same friend to the database. Let's switch to Visual Studio. Here I've opened the Friend Organizer solution. Now let's start the application. I press Windows key and arrow left to move the application to the left side of my screen. As I want to see the effect with two users, I need to start another instance of the Friend Organizer application. So I go to the Solution Explorer, I right-click on the Friend Organizer UI project, and I select Debug Start New Instance from the context menu. I press Windows key and arrow right to move this instance to the right side. Now we are running two Friend Organizer applications. In both applications, I open up the friend Sarah Huber. Now on the left side, I change the first name to Anna, and I save that friend back to the database. Now on the right side you can see that the first name is still Sarah. The user does not know that another user has changed this first name already in the database. Now I change it here to Julia, and I click Save. I don't get any notification that the data has been changed by another user, and my data just overwrites the data in the database. So Anna doesn't exist anymore, now it's Julia. You can see this effect when you close the tab in this application, and when you reopen the tab again, the friend is loaded and now it's Julia here as well. So the default behavior of Entity Framework is last wins. The changes of the user who clicks the Save button last will be stored in the database. This is okay for some applications, but for some it's not. In some applications, you want to tell the user that the data has changed in the meantime when he clicks the Save button. You will learn how to do this in this module by using Entity Framework with optimistic concurrency. Let's take a look what possibilities you have to handle these concurrency conflicts in an application. There are two common approaches how to handle concurrency conflicts in your application. One approach is to use pessimistic concurrency. This means that you lock the database record when a user is editing that record, so other users can't update this record in the meantime. While this approach is safe, it can lead to many locks in the database and you might produce a deadlock. Imagine if your application has thousands of users, how many locks the database has to create when the users are editing your data. This means with pessimistic concurrency your application might not scale so well. So instead of being pessimistic with database logs, you can also be optimistic and solve the conflicts without database logs. Optimistic concurrency means that you check if the data has changed in the meantime when a user tries to save it back to the database. To do this, you can compare every single field of the loaded entity and of the record in the database, or you can add a version column to your record. If you have such a version column, you have just a single comparison to do. When the user tries to save an entity, you just check if the version of the loaded entity is equal to the version of the record in the database. If that's not the case, that means that another user has edited this entity in the meantime. Then you can tell your user that the data has been changed, and you can ask them if they still want to save their data or if they want to reload the data from the database. Now let me show you how you can implement optimistic concurrency with Entity Framework. To use optimistic concurrency with Entity Framework, you can add a row version property to your entity of type byte array. Then you just add the timestamp attribute to this property. The attribute is called timestamp because older versions of SQL Server had a timestamp data type. With SQL Server 2008, the data type row version was introduced. When you create a DB migration for this row version property with a timestamp attribute, Entity Framework will create a row version column in the database of type row version. This column is automatically updated by the database when the record is updated. The row version is a sequential number. In an update statement, Entity Framework will create a where condition where it checks that the row version in the database is the same as the row version of the entity it tries to save. If that's not the case, no record is found to update, and Entity Framework will throw a DB update concurrency exception that you can handle in your code. Later in this module, I will show you the where condition that Entity Framework creates for the row version. In the Friend Organizer application, we are using attributes on our entities and not the Fluent API, so we will use this timestamp attribute in this module. If you are using Entity Framework with the Fluent API, you can use the isConcurrencyToken method to specify the row version property as a row version for optimistic concurrency. Now let's continue in the Friend Organizer application and let's add the row version property to the friend entity.